Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Put 85 into 81. I'm not really sure what that's... no, I still don't really know what that's referencing. 81 is obviously the number of cells in a 9 by 9 grid, but I don't know what 85 is. Anyways, this is by EPH, and let's get to the rules. We have standard Sudoku rules apply, which means each row, column, and 3 by 3 box must contain all the digits from 1 through 9. We have XV clues, where digits separated by an X sum to 10, and digits separated by a V sum to 5. So, for example, if this were, say, a 7 here, this would have to be 3, because these two digits must add up to 10, because there's an X between them. If we had a 3 here, this would have to be a 2, because these two digits must add up to 5, because there's a V between them. And we have renbands, where digits on a pink line are a non-repeating set of consecutive digits in any order. So say we had 3 there, we could have, say, 6, 5, 7, and 4 here, and that would be valid because these would form a set of non-repeating consecutive digits, or a non-repeating set of consecutive digits. What you could not have, though, is something like 8 here, because 3, 4, 5, 6, 8 does not form a set of consecutive digits. So those are possibilities. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. These digits, which have an X between them, are also on a renban line, which means they must be on a set of digits which are consecutive, with 4 digits total. 1 9 doesn't work. That you can't have a set of 4 digits that are going to be consecutive, including 1 and 9. 2 and 8 doesn't work. Again, no 4 sets of consecutive digits that are different, that have 2 and 8 in them. 3 and 7 doesn't work, because again, 3 can only go up to 4, 5, and 6. 7 can only go down to 6, 5, and 4. So this pair of digits that are all on X's on a renban, a 4-length renban, I should say, have to be 4 and 6. Okay, that means we are guaranteed a 5 on this renban. So this 5 means this can't be 5 here. Where is the 5 on this renban here? Because we have to have a 5 to form a consecutive set. It's either 3 through 6 or 4 through 7, both of which contain 5. So 5 being one of these means this can't be 5, so 5 has to be there, which means this can't be 5. Where's the 5 on this renban? It must be here, which means this can't be 5, so 5 has to be there, which means this can't be 5, which means that's a 5 there. Well, any 5-length renban also has to contain a 5, because the consecutive sets are 1 through 5, 2 through 6, which has a 5, 3 through 7, which has a 5, 4 through 8, which has a 5, and 5 through 9, which has a 5. So that means the 5 here has to be somewhere on this renban, cannot be here or here. So it's one of these two, which means this can't be 5. 5 can't be here because of 5 in the row. 5 can't be here because of 5 in the box. So 5 has to be there. That means this can't be 5. No 5 here because of 5's in the column. No 5 here because of 5 in the box. So 5 has to be there. Same with this. And this is actually all kind of symmetrical except for this portion. So 5 has to be there, and then 5 is there. We have 8 5s now. We know where the last 5 has to be. It has to be there. So this must be 3 or 7 here to be in a 4-length renban with 4, 5, and 6. Same with this. This is 3 or 7, 3 or 7, and 3 or 7. But these are different 3 or 7s here. We're going to color this one blue. This one must be red. That means this can't be red. That's blue there, which means this can't be blue there. It has to be red. We also know these red bands are 5 length. Well, we have a guaranteed 4 or 6 here. So that precludes any of these from being 1 through... sorry, it cannot be any... It has to either be 1 through 5 or 5 through 9. Because every other combination of consecutive Ren bands, a consecutive set of digits, would have to include both 4 and 6. And it's the same for every set of these 5 digits. So these have to be the same set. So it's either 1 through 5 or it's 5 through 9. We're going to make these green. That means this cannot be green. So if this is 1 through 5, this can't be 1 through 5. The remaining digits here have to all be the other set of digits, right? 1 through 4 could be here, or it could be 6 through 9 here. Either way, these have to be the other set. So these also have to be consecutive because we have a 4, 6 only as a possibility here. So these all have to be orange. Since this is orange, this must be green there. Interesting. So we have 4 oranges in this upper right-hand box. That means the rest of the box cannot be orange. They have to be all green here. So this is green. That's going to make this orange, which makes this green, which makes that orange there. 4 oranges are here, so these must be all green. That means all of these are green, which makes these all 4 oranges there. Therefore, these are orange, which makes these all green. We have 4 oranges in this upper left-hand box, this lower left-hand box, and this lower right-hand box. We have 4 of the same color, so the other ones have to be opposite colors. So we have orange here, green here, this is orange here. Okay. So we have an orange-green pair here, which means this must be an orange-green pair here. That's interesting. And this must be an orange-green pair there. Huh. So since this is green, to add up to 10 with the opposite, you have to have the orange there. These are going to be the same set, because we can't have a 5 on them. So we have the divided into the lows and the highs. The lows being 1 through 4, the highs being 6 through 9. Okay. These are the same set because there's no 5 available. And we have 3 greens in row 2. So these cannot be green, they must be orange. And to be consecutive, you don't have a 5 available, they have to be the complete set of 1 through 4 or 6 through 9. We're not sure which. Anyways, in this upper central box, we have 4 oranges, so the rest must be green. These are all orange. So these are green. These are both low because they add up to 5. And it's either 1, 4 or 2, 3. These are the same problem. So these 3 cannot be orange because we have 2 oranges already in the row. So these must both be, these all must be green. So that makes that green because there's no 5 available there. We have 4 greens in this left central box. That leaves the remaining digits as orange. We now have 4 oranges in row 4, which means the remaining digits in row 4 have to be green. Well, if blue were the same as green, we'd have 5 blues in the central box, which is obviously not possible because we only have 4 possible digits there. Therefore, greens have to be highs, and oranges have to be lows. So these are lows. So this must be 3 here. That's 4 there. That's 6. That leaves us a 7, 6, and 4. 3, 4, and 6. 7, 6, and 4. And we have 4 lows in column 5 now, which means the rest are high digits. We have 4 high digits in this lower central box, so that eliminates high digits in the rest of the box, so these are low. We have 4 high digits in column 4, so this must be low. We have 4 low digits in the central box, so this can't be low, it's high. We have 4 high digits in row 5, so these must both be low. And we have 4 low digits in row 6, so these must both be high. Okay. This has to be 1, 2 added with 8 and 9 there. This is 8 or 9 here. So this is 1 or 2. This must be 1 through 4 and 1 through 4 there. This must be a 1, 2 pair in these 2 cells. Same with these 2 cells. That means this is a 3, 4 pair here. 3 and 4 add up with 6 and 7 to add up to 10. The 3, 4 pair here eliminates 3, 4 in the rest of the box. That's 1, 2. That 1, 2 pair eliminates 1 and 2 in the rest of the column. So, and these add up to 5. Therefore, these other ones must also add up to 5. So since this is 3 or 4, that's 1 or 2. This must be 1 or 2 here because that's the only digit remaining. That leaves this as a 3, 4 pair here. 4 eliminates 4 here. So that's 3, which makes that 4. This is 1 or 2 remaining here. This is 8, 9 as a pair. That leaves us as a 6, 7 pair here, which leaves us as 8 and 9. That leaves that as 6, 7. This 6, 7 pair eliminates 6, 7 in the rest of the column. So that's 8 and 9. This is 1, 2, and 3 left. 2 has to be one of these digits. It's either 1, 2, or 2, 3 here to be consecutive. So no 3 here, therefore this can't be 2. This is 1 or 3 with 7 or 9 there to add up to 10. Whereas 4 in this box, it has to be here. This is again 1, 2 with 8, 9, adding up to 10. This has to be 1 or 2 because we have 3 or 4 in the row. That leaves us as a 3, 4 pair. We have a 3, 4 pair in column 6. That eliminates 3 and 4 in the rest of the column. So no 3, 4 there. No 1, 2 there to add up to 5. That leaves that as 1, 2. So this is guaranteed to have an 8 here. So this could be 7, 8, or 9 to be consecutive. This can't have an 8. It's 6, 7, or 9 there. We have 8 or 9 remaining here. 8 and 9 remaining here in column 7. This is 1, 2, or 3. We have all the 4s, kind of. 6 and 7 means this can't be 6 or 7. It's 8 or 9. We have an 8, 9 pair in the central box, so that leaves us a 6 or 7. 8 or 9 cannot be any of these digits, so it would have to be 8 or 9 there. This would have to be a 1, this. Okay. Remaining digits here in column 3 are 1 or 2. This 1, 2 pair eliminates 1, 2 here, so this is 3. We have 8 guarantee here, so this cannot be 8. It's 6, 7, or 9. We have an 8, 9 pair here. That eliminates 8 and 9 in the rest of the column, so it's 6, 7, 6, 7 as a pair, which eliminates 6, 7 in the rest of the box, so this can't be 7. It's 9, which makes this 1, which makes that 2, which makes that 3. 9 eliminates 9 here, so it's 8, which eliminates 8 there, so it's 9. 9 eliminates 9 there, so this is a 6, 7 pair. That eliminates 6, 7 in the rest of the row, so this is 8. This is 7. 7 eliminates 7 there, so this is 8, 9 pair. That eliminates 8, 9 in the rest of the column, so this can't be 9. 1 eliminates 1 here, so that's 2 and 8 to be add up to 10. 1 and 2 eliminate 1 and 2 there, so it's 3. That leaves that as 1 there. That's 2. This can't be 2 because of 2 in the box, so that's 1 and that's 2. 2 eliminates 2 there, so it's 1 and 4 adding up to 5. 4 eliminates 4 there, so it's 3, which makes this 4, which makes that 3. 3 and 7 add up to 10 here. That leaves that as 6, which makes that 7. 3 eliminates 3 here, so it's 4 and 3. 2 eliminates 2 here, so it's 1. 1 eliminates 1 here, so it's 2 and 1. 1 eliminates 1 here, so it's 2 and 1. 1 and 9 add up to 10. 1 eliminates 1 there, so it's 2. 2 eliminates 2 here, so it's 1 and 2. 2 eliminates 2 here, so it's 1 and 2. 9 eliminates 9 there, so it's 8. 9 eliminates 9 there, so it's 8 and 9. 7 eliminates 7 there, so that's 6. Which eliminates 6 there, so it's 7. 7 eliminates 6, 7 there, so it's 6. 6 eliminates 6 there, so it's 7 and 6. 8 eliminates 8 there, so it's 9. 8 eliminates 8 there, so it's 9. 9 eliminates 9 there, so it's 8 and 9. 6 eliminates 6 there, so it's 7. 9 eliminates 9 there, so it's 8, which makes that 9. 8 eliminates 8 there, so it's 9. Remaining digits in column 4 are 6 and 8. This can't be 6 because of 6 in the row, so that's 8, which makes that 6, which makes this an 8, and therefore this is a 7. And that's how you solve it. Yep, fairly straightforward. Nice coloring puzzle. I don't understand what the put 85 into 81 still is, though. I don't know. It's just a reference that I don't get. But it was a nice geometry behind this puzzle. Yeah, it was just really cool design, and the solving was really nice. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.